So there's no loss of packets.
In principle, there's no loss of packets. That's right.
Higher chance of them being.
There's a higher chance of them being in order. That's right. There's no guarantee that they'll be in order, but the entire argument here is that, like I said, this is all in a close physical proximity, and it's on presumably private networks. So there's no congestion issue. There's there's very little latency issue, and so if you do receive packets out of order, there won't be very many of them. So you won't have a scenario where you're waiting 100 packets to receive one that's out of order.
So how many networks will be connected to each router?
It's a good question. I actually don't know.
What if there's the mobile is moving from one router area to another router? Is that still possible?
Oh, I see what you're saying. So
Another router, other stations.
Right. So, I mean, mobile. What's happening up here, up to this line, it's all mobile IP. So if you exit this cluster and go out here to another cluster, everything that we talked about previously will happen. So you'll have all the registration messages will have to be passed all the way back to the home agent and so forth. Yeah. So basically, what's going on here is that these guys are all close together. So probably if you move, you'll be moving amongst these guys. But if you don't, the passing of all the mobile IP control messages will happen much less frequently because you won't be doing this very often. Yes.
So you basically just increase the floor number, the size of the floor.
Exactly. That's the perfect way to think of it. Is that you expand the size of the FOR network by a factor of however many base stations are attached to this router.
And as far as mobile IP is concerned, it doesn't see the difference and it doesn't care.
Exactly right. Yeah. Exactly right. Yes.
Who has this COA?
The COA is so all along we've said that the COA address is kept at the foreign agent, so that's still kept up here. So I mean, above this line, everything is mobile IP. Below this line, it doesn't even have to be IP. It can be a proprietary technology, although it is called cellular IP, so the presumption is that everything that happens below this line will also be an IP-like network. Yes?
Is there an equation for when the size of the floor network is so large that it would actually be more efficient to create another floor network? As in, like, the time it takes to route the packets?
Good question. I would actually say it's not necessarily the time it takes. Okay, yeah, it would be two things. So for one thing, if this is a network over an enormous area, then latency starts becoming an issue. But also, if this becomes a network over an enormous area, there's lots of mobile nodes moving from network to network. So now the bandwidth of all these links becomes an issue. So the amount of routing you can do is limited. I'm sure you could write something down. Maybe I'll think of an example for next time. Anything else? Okay, so.
Couldn't you just do that? Put another router on top of the foreign agent there, and then just have like even more of an internal system?
Sure. Okay. Now we're starting to get into the problem I talked about when we started talking about mobile IP. Basically, you're pushing the routing problem up and up and up. So now the problem starts becoming your routing tables are getting too large.
But assuming like it is a cell phone something, and my customers are talking to my customers.
I'm actually not sure where the trade-off point would be. I'm not sure how big these clusters should be. I was actually looking to see if I could find details on commercial implementations of this, but I couldn't just before class. But maybe I'll write down an example and try it next time. Okay, so up until this point, so just as a closing statement, all we're doing here is instead of treating everybody individually, we cluster things geographically, which improved latency and performance. So packets are rarely lost. Our packets are much more rarely lost because we don't do that complicated handover procedure very often.
Sorry, I got one question.
Yeah.
If corresponding node is another mobile node,
yes.
smart enough to know that I'm on the same.
Okay, good question. So let's say I have a CN over here, and I'm talking to a mobile node within the same.
But my home network address, that was just
Well, if you have the same subnet IP or something.
Yeah.
but maybe he doesn't know that I think my IP is my home network.
That's true, but if you're talking over the internet, it might be resolving an IP address that's far away anyway.
Yeah.
So it may not, I don't know. It could
I'm- So I'm trying to think of a practical example where this would occur. So basically, you'd have a handheld. You'd have a handheld talking to another handheld. So I can't think of. There aren't too many applications where that would happen. So even if you're doing like chat or something, it's usually bouncing off a server somewhere else.
Unless I'm using a Rogers service or.
Okay, yeah, if you're using some private Rogers service or something.
You're checking your bill on your cell phone on a web page or something. I don't
It's crappy Rogers Labs, right?
know. Yes. So
Yeah.
so do we- so-
I don't know. I honestly don't know if they would if the routing would be smart enough to
Yes,
pick up on the fact that it's in the same subnet.
I think for some of those data services, they don't count the data if the stuff that you were browsing is on their network. So I don't know if that's them actually not needing the internet at all, or if that's just them subsidizing it because you're watching their ads or something.
That's the whole net neutrality.
Okay. Anyway, so the short answer there is I don't know.